Hello. In today's lesson, we will discuss a new concept, and that is electric potential. What does potential means? Well, if I raise an object, it has potential energy. Why? Because it has the ability to do work. Potential is actually the ability to do work. What is electric potential? It is useful to compare electric potential to gravitational potential. So let's compare gravitational and electric fields. When you have a gravitational field, you have a gravitational potential. Similarly, an electric field will then define an electric potential. You are familiar with gravitational potential energy. Now, if I want to raise an object through a height h, then the force I apply will do external work. Now, when I use the force and that force moves in the upward direction, the gravity also is applying a force. See, if the force I apply is upward, the gravity applies will be downward. Therefore, if the work I do is positive, the work gravity does will be negative. So an external force does work against gravity to raise the object, to raise the potential energy. The work done by gravity on the object will be negative. I hope you understand that concept, because the object is moved up. The applied force is also upward. The direction of the force and the direction of displacement are the same for the external force. That means that work is positive. But the direction of the force of gravity is downward. And when you move the object upward, the work done by gravity is negative. So, the negative work done by gravity raises the potential energy. Now that concept is very important. So gravity does negative work. Now, when you allow the object to fall, the displacement and the direction of the gravitational force are both the same. That means when the object falls, gravity does positive work. Therefore, tell me, what is the total work done by gravity in raising the object and then bringing it back to its original position? While raising the object, the work done by gravity is negative. While the object falls back, the work done by gravity is positive. So what is the total work done when the object is raised through that closed path? You see, when I raise the basketball, the work done by gravity is negative. When I drop the basketball, the work done by gravity is positive. The total work done by gravity in that closed path is zero. Now, what do you call such a field? We talked about it in Physics 1. You see, a field where the total work done in a closed path is zero is called a conservative force field. Now, this work done by the external force gives the object a potential energy U. So the work done by the external force raises the potential energy, which is the same as saying that the negative work done by gravity raises the potential energy. The potential energy, therefore, is a measure of the negative work done by gravity. I hope that concept is clear. It's very important to know that. When the object is allowed to fall, the gravity does positive work. So positive work by gravity lowers the potential energy, and the negative work done by gravity increases the potential energy of the object. The net work done on the object by the force of gravity in the closed path is zero. A force field where the net work done in a closed path is zero is called a conservative force field. Gravitational field is a conservative force field. In the same way, electric field is a conservative force field. You see, the motion of an electric charge in an electric field is the same as the motion of an object in a gravitational field. Potential energy in a conservative field is the negative of the work done by the conservative force. In a gravitational field, the conservative force is the gravitational force. In an electric field, the conservative field is the electric field. Now, how do I write this in a mathematical notation? We say U stands for the potential energy. The potential energy is negative of the work done by the conservative force. F dot ds is the small amount of work done by this force when the displacement is ds. And integrating that work through the entire displacement will be a measure of the potential energy. Now, like gravitational field, electric field is a conservative field. Here we study the motion of electric charges in an electric field, just like we study the motion of objects in gravitational field. In electric field, we study the motion of electric charges. But there is a small problem with the electric field. There are two types of electric charges. So which one do we choose as our test charge? Well, we have settled on it long ago. What is our test charge? Our test charge is a positive charge. We have chosen a positive charge as a test charge. Therefore, we will now be talking about the motion of positive charge in an electric field. Now, a positive test charge is placed in the electric field produced by this positive charge. Now remember, the electric field due to a positive charge will be diverging from the charge. The field lines will be originating from it. So a positive test charge is placed in a field produced by a positive charge. An external force has to do work to move the test charge from A to B. You see? Because the field is directed away from the positive charge, if you want to move a positive test charge towards the positive charge, an external force needs to do work. In the same way, when you want to raise an object in the gravitational field, an external force has to do work. So, moving a test charge towards a positive charge is like raising an object in the gravitational field. An external force has to do work to move this positive test charge from A to B. Now tell me, when the object is moved from A to B, is its potential increasing or decreasing? When the positive test charge is moved from A to B, its potential increases. So the electric field does the negative work on the test charge, increasing its potential energy. So when the external force moves the object from A to B, you can see the external force is directed from A to B. If that work done is positive, then the work done by electric field will be negative, because the electric field is directed from B to A. So In order to increase the potential energy, we move the test charge from A to B. And when you do that, the electric field does negative work on it. Therefore, how do we measure or how do we define electric potential? The electric field does negative work on the test charge, increasing its potential. That means the negative work done by the conservative electric field is a measure of the increase in potential of the test charge. When the test charge is allowed to move, if you now leave that test charge will fall back to A. Just like the basketball falls back to a lower potential. When you allow the test charge, after placing it at B, if you allow it to move, it will move back to A and it will move away. What is the direction of motion of a positive charge in an electric field? You can see, if you leave the positive charge, it will move away from this positive charge in the direction of the electric field. Now, when it does that, its potential decreases. Therefore, we can very conveniently say that the direction of an electric field is the direction of decreasing potential. When the test charge is allowed to move, it falls to a low potential in the direction of the electric field. That means when the electric field does positive work. When the electric field does positive work, it decreases the potential of the test charge. Therefore, the potential decreases in the direction of the field. A very important concept. The direction of an electric field is the direction of decreasing potential. The electric field is directed from B to A. B corresponds to a high potential and A corresponds to a low potential. The direction of the electric field is the direction of decreasing potential. The potential energy of a test charge at infinity will be zero. If you leave the test charge, it will go all the way to infinity where its potential energy will be zero. So we will assume that the potential energy is maximum near the positive charge. And as you go away, the potential decreases. When the test charge is moved opposite to the direction of the field, the gain in potential energy is a measure of the negative work done by the electric field. I am repeating this concept because it is very important. When you move the test charge opposite to the electric field, the gain in potential energy is a measure of the negative work done by the electric field. Electric field is a conservative force field. And we write it like this one more time. The gain in potential energy U is the negative of the work done by this conservative force field, which is the electric field now. The same statement we made for the gravitational field.